What's up friends, today we are going to study relation of discrete mathematics. This is the first video of relation. In this video we are going to cover binary relation and properties of binary relations like reflexive, irreflexive, symmetric, antisymmetric, asymmetric and transitive. So let's get started. So here we have definition of binary relation. Any subset of A cross A is said to be binary relation on A. For example, if we have a set A which contain element 1, 2 and 3 and we have to find the Cartesian product of A and A, the cardinality of the Cartesian product of A and A is 9 and the elements inside the Cartesian product of A cross A is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3 and so on. So the subset of the Cartesian product of A cross A is said to be binary relation on A. Number of binary relation on set A. If we have given a set A whose cardinality is n, then the cardinality of Cartesian of A and A is equal to n into n, which is equal to n square. So number of binary relation means number of possible subset which can be formed on the Cartesian product of A and A. So we know the formula that number of possible combination of subset is 2 to the power cardinality of the set. Here the cardinality of the set A cross A is n square. So the total number of binary relation on a set A is 2 to the power n square. So here we have our first properties of binary relation, which is reflexive. According to this property, if we have a element A which belongs to the set A, then the pair A comma A should belongs into the relation, or self pair of all the element should be present and additional pair is acceptable. Let's take an example. If we have a set A which contain element 1 and 2 and we have given two relation R1 and R2. The relation R1 contain a pair 1, 1. The relation R2 contain pair 1, 1 and 2, 2. So here relation R1 is not reflexive because it does not contain 2, 2 and we need a self pair of all the element. Relation R2 is reflexive here. Now our next property is irreflexive. It states that for all element A which belongs to the set capital A comma A does not belong to the relation, or no self pair is acceptable in the relation. If we have a set A which contain element 1, 2 and we have a relation R which contain a self pair 1, 1, then this relation is not irreflexive. But if we have a relation R which contain a pair 1, 2 then this is irreflexive. Now here we have the third property, which is symmetric. For all element a comma b which belongs to the set A, if a comma b belongs to the relation R, then b comma a should also be belongs to the relation R. This means if a comma b belongs to R, then its reverse should also exist in the relation. Let's take an example. If we have a set A which contain element 1, 2 and 3, and we have a relation R1 which contain pair 1, 1, 2, 3, then the relation R1 here is symmetric. Now the fourth property is antisymmetric. For all A and B which is belong to A, if a pair A comma B belongs to R and B comma A belongs to R, then A equal to B. This condition should satisfy. Or there is no reverse pair of a pair but self pair in antisymmetric is accepted. Let's take an example. If we have a set A which contain element 1, 2 and 3, and we have a relation R1 which contain pair 1 comma 2 comma 2 comma 1, then this relation R1 is not antisymmetric. If we have a relation R2 which contain pair 1 comma 1 comma 1 comma 2, so the relation R2 is antisymmetric because here self pair is accepted but no reverse pair is accepted, and in the relation R2 we have a self pair but no reverse pair. The fifth property is asymmetric property. For all elements A comma B which belong to the set A, if A comma B belongs to relation, then the pair B comma A should not belongs to the relation, or there is no reverse pair of a pair is allowed and also no self pair. Let's take an example. If we have a set A which contain element 1, 2 and 3, and we have a relation R1 which contain pair 1 comma 1 and 1 comma 2, so the relation R1 is not asymmetric because it contains a self pair. If we have a relation R2 which contain pair 1, 2, then it is asymmetric because it does not contain reverse pair. So here we have our last property, which is known as transitive property. For all A, B, C elements which belongs to the set A, if a pair A comma B belongs to relation and a pair B comma C belongs to relation, then the pair A comma C should also belongs to the relation. Let's take an example for this. If we have a set A which contain element 1, 2 and 3, and we have relation R1 which contain pair 1 comma 2, 2 comma 1, 1 comma 1 and 2 comma 2, then this relation is transitive relation. because we have a pair 1 comma 2 and 2 comma 1, so we need a pair 1 comma 1, and we have a 2 comma 1 2 comma 1 and 1 comma 2, so we need a 2 comma 2 pair. Now take another relation R2 which contain pair 1 comma 2 and another pair 3 comma 4. This is also a transitive relation.
So friends, if you find this video helpful, please like, comment and share this video with your friends, and don't forget to give your feedback and subscribe to my channel. Thank you. See you next time.